Welcome back to another edition of the Southwest Climate Podcast. Mikey?
Zacky? Bi-monthly podcast? Take it again?
Don't ever call me that again. Yeah, that's right. We skipped October.
Yeah,
what the heck happened in October?
Not
with the climate. We'll talk about that.
No.
But why didn't we do October?
I think we were trying to be spooky for Halloween.
I think life just got busy.
Yeah, I think all three of us were out of town for much of October. You went to Italy.
Yep.
Ben went to Louisiana, and I went to Globe.
Saw my people.
You did? That's
Yeah.
right. How was the coffee?
Well, the coffee's better here, to be honest with you. Europe, they're still on this espresso thing, and I think they miss
This espresso.
This isn't a coffee podcast, although it should be.
That could be our spinoff.
I probably have more expertise in coffee than I do about climate.
I feel like I have a better handle of coffee as well.
All right. Well, yeah, it's been, the last time we were here.
It was still the monsoon season.
It was still the monsoon season.
Yeah, you were flying high. Monsoon was still rolling along.
There's a lot that's happened in the meantime.
A lot happened. You weren't even here for most of it, were you?
October was amazing. We'll get into October.
Yeah.
Let me just go over the outline for those who
for me as well
are deciding if they want to stick with us.
Yeah, this is a good time to opt out.
We'll spend just very briefly revisiting the ranks of the monsoon.
I'm going to give you 30 seconds.
Maybe a minute.
You're going to wrap it up. Okay.
Just to put the monsoon in its proper resting place. Okay. And then we'll move on, talk about what happened in October. Mm-hmm. October was very eventful, in many ways more eventful than parts of the monsoon.
Yep.
Bring you up to speed in November, and then look forward with El Niño. And we'll deconstruct a little bit of some of the science that's out there on El Niño. Try to have a more nuanced conversation about ENSO. What do you think?
Okay, fine, whatever.
Really? Do you have something else in mind?
No, just going back to ENSO again. I just bring that up this time of year.
So the monsoon, let's just revisit this. Like I said, we'll start at a city level. Tucson, out of 71 years, came in at 20th. 20th out of 71. 28 out of 72 in Phoenix. Flag, 14 out of 69. These periods of records are changing just because...
Yeah, how many years for each station?
Yeah, the station changes. And those are at the airports. Obviously, there's a lot of variability within those areas themselves, which we've talked about a lot. Prescott, 9 out of 58. Kind of the big winner. And then moving over to New Mexico and northern Texas, El Paso was 49 out of 78. All right, so Albuquerque, 25 out of 73. They got close to 5 inches of rain, which is 114% of average. Looking around the state, and again on Mike's website, he's got 42 stations that he's monitoring that have data. Some of them
don't anymore. Yeah, some of them actually shut down.
But there's 42 that are reporting. The driest one came in at third. It ranked third, and there was a tie in terms of ranks between Happy Jack, Arizona. And then the other one is near Farmington, New Mexico, Aztec Ruins.
Yeah, I could imagine that the far northeast part of Arizona and the far northwest part of New Mexico did not have a banner monsoon season. And so that was the place where the drought monitor is definitely lagging, rightfully so. The drought conditions are still quite bad up there.
And then the wettest rank was also third, and that was near Williams, which is just west of Flagstaff. I don't know how to pronounce this, Mike. Seligman?
Seligman, yeah. That's
not surprising because that area was quite wet.
Yeah, the Happy Jack, I just pulled it up. It's really surprising. And I had talked to some ranchers up along the Mogollon, and they had noted that some places just got hammered through the monsoon and then did quite well with the October rain, which we'll talk about. But there were some definite dry spots. And we know that happens during the monsoon season. Even in a really busy one, there are going to be places just by chance are just going to get left behind.
All right. And then finally, looking at those 42 stations, 26 of them were average or above average, and 16 of them were below average. So yeah, spatial variability, more good than bad, if you will. A couple take homes, like really no firsts in either dry or wet. Middle of the road, tilting slightly to better than average for the most part. So yeah, that's the monsoon.
Excellent.
I'm over it.
Put a bow on it. Let's move on.
I'm over it.
Yeah, I was good. What's your memories now? What's your memory? Tell me how you feel about the monsoon 2018.
I think it was eventful, and I think it was pretty active throughout much of the monsoon. It came on with a bang and it ended with a bang.
Yep.
And I felt like I said this last time, and I think you did as well. I felt like it sort of underperformed given the amount of moisture that was around. And again, I think that the take home point is that there's a lot of variables that have to come together on any given day to like actually wring the atmosphere of water. But it wasn't a year in which there wasn't any moisture around. So
yeah,
the
I agree.
Potential was there.
Totally agree with you. Yeah, July, August, September precip rankings, most of the state came in interestingly near normal. So that'd be July, August, September. Far northeast part of the state did have pockets of much below, and then a couple of spots of record driest with some of the gridded data. So that's actually quite interesting.
You think that's real?
It's a tough area that we don't have a lot of monitoring up there. So
and that's the Four Corners?
That's Four Corners. I think that's actually right around Hopi, and I do know that Hopi ended up having a very dry summer. Far northeast, far northwest areas of Arizona, New Mexico did not have the same monsoon that the rest of the region did. Everybody else, for those 3 months, not too bad. Active, really interesting, a lot of variability in the kind of weather we saw. So
then the monsoon hurricane, tropical storm Bud, or the remnants of Hurricane Bud, was a hurricane, I believe, sort of ushered in the monsoon literally on June 5th, June 15th.
Mm-hmm.
And then literally on the end of the monsoon,
September 30th,
we had another tropical storm that ushered in October.
I know.
Rosa, right? We got the thumbs
names
up on
right.
that.
Okay, good. We're trying to get all of our names right. There were so many storms in the Pacific. It was hard to keep track.
Yeah, so October, by my estimate, well, first I should say that for Tucson, October generated 2.6 inches of rain, which turned out to be, so far, the most precipitation of any month this year.
That's amazing, isn't it?
Yeah, it's pretty cool.
And if we think back, the almost 20 years I've been here, I'm sure it was the wettest October I've seen since I've moved here. And Octobers in general are not necessarily wet months, but they can be the wettest months of the year when they are wet. So it's a very interesting month because of the impact of tropical storms.
So I just so happen to have that data. So the wettest October in Arizona, averaged over Arizona, looks like it was 72, followed by 2000. And then it looks like, something before 1900, which I'm not sure I believe. I don't know. Should I not believe that?
I don't know. It's your problem. It's not my problem. I have no idea.
But, so this year was somewhere between the third and the fourth wettest October. So by my estimate, Mike, and maybe you can narrate this a little bit more, but there were 4 distinct events in Arizona. We had one in the early part of October, like around October 1 through 4, the remnants of Tropical Storm Rosa. Then not too long later, October 6th, 7th, mainly in the northern part of Arizona, there was another event. And then around mid-October, somewhere between the 13th and 18th, depending on where you are, there was another event. And then, October 23rd, 24th, there was the final event.
I want to just talk a little bit about the East Pacific hurricane season, tropical storm season, and I'm pulling up the Southwest Climate Outlook. So Ben McMahon wrote this up in the most recent SWICO, and he noted that there were 23 named storms, including 10 major Category 4 or above hurricanes this particular season. And it was also the most intense Pacific hurricane season on record. So they have this accumulated cyclonic energy index of 317, and that broke the record of 295 set in 1992.
So that's a measure of not just the frequency of these hurricanes, but also their duration and intensity. So it's an integration of, which is a better measure of sort of the
you could have a bunch of storms that were marginal, and you could have a bunch of storms that were strong. So it would distinguish between those two elements. So it was a very, very busy East Pacific season, and I think that we knew going into the monsoon season that that part of the East Pacific was primed. We were drifting towards El Niño, lots of above average sea surface temperatures in the East Pacific. So the conditions were right to have that activity, and we really lucked out in having the recurvatures that we thought might end up happening. That's true.
Wait, we lucked out by having some hurricanes recurve back into the Southwest?
Yeah, we really did. Yeah, like we didn't see that coming. We knew that, it's the conditions were right and those things were going to fire off.
Baja California might not think that.
No, I don't think they do. And I think much of Mexico. I mean, these are very destructive storms. And I think we saw at the later part of the month where Hurricane Willa made landfall and
Sinaloa.
It wreaked some havoc down there. And then it moved across Mexico and then flooded out Texas. So Texas ended up having quite a bit of rain.
Of the 23, there were 4 that recurved back into the mainland.
Yeah, and they were all, as you'd expect, late transition season.
Except for Bud. Bud was
early season. Yeah. That's right. Yeah,
and that was an interesting sort of synoptic pattern that set up, right? It was it was kind of like a transition season.
Yeah, it was transition in and transition out. Is when we picked up these storms.
So you had like a trough moving down, and basically that helped as as Bud sort of wafted north, it got entrained in that eastward moving air and recurved back in.
Yeah, and if you think about just the real basic mid to upper level circulation patterns from the spring to summer to fall, there is typically kind of an upper level. We're in the westerlies, let's say that in the spring. So over Arizona, there is air moving from west to east, and so that's typically moving at mid levels, drier air inland. And as the continent heats up and the subtropical ridge builds north, and we get into the core of the monsoon season, the ridge is overhead, and Arizona, if we're lucky, we're in easterly flow, which can then help sort of guide in the subtropical moisture. But at the same time, tropical storms are also getting caught up in those easterlies. Those easterlies are going to redirect and move most of the storms that form off the southern coast of Mexico out to sea. And that's what you see in the storm tracks for the whole East Pacific. Almost all of them are moving from east to west, right? And it's only at the transition season where we have some westerly component over the East Pacific that's going to drag those things up across the Southwest.
No, but there's a few other points that you brought up. It's sort of the climatology of the tropical storms. And on average, it's about 15 named storms and about 7 hurricanes. So that would be categories 1 through 5. And then 3 major hurricanes would be categories 4 and category 5. This year, then, in the East Pacific, we were, as Mike said, 23. So that's substantially above the 15. 12 hurricanes, substantially above that 7.5 on average. And 9 major hurricanes.
Right.
In fact, actually, the prediction coming into the season was for above average for the reasons that you suggested.
Yeah. I think we leaned into it because the conditions were right, and that turned out to be a pretty easy forecast.
And so there was real warm sea surface temperatures.
Yeah, still are. Yeah.
And then the ENSO event that was emerging, the El Niño, that has a tendency to reduce wind shear.
Yep.
And a reduction in wind shear then allows these storms to sort of generate.
Yeah, and there's this other interesting bit of research that's come out in probably the last 10 years about the sea surface temperature pattern from the East Pacific north, and it's called the Pacific Meridional Mode. And so it's looking at the pattern of sea surface temperature patterns instead of east to west along the equator, as we do for ENSO, El Niño Southern Oscillation, looking at it north up along the coast of Western North America. And we've been in this sort of warm pattern for several years now since the sort of transition that we saw like 2014. Kind of the onset of that El Niño event there was a shift in this Pacific Meridional Mode, which is, kind of still being researched. I don't totally I think there are clearly people who understand it. I don't understand it as much. It's related to some of the North Pacific oscillation activity, which is also then connected back to ENSO variability at longer time scales. But there are some of these other sea surface temperature patterns, I think, kind of set the stage for that East Pacific activity. And this Pacific Meridional Mode has been linked to East Pacific tropical storm activity in some of the research as well. So that and ENSO, so as you're saying, ENSO giving a favorable upper level environment sort of socked in with this sea surface temperature pattern as well. Good conditions to fire stuff off.
And the season itself ends basically in November. That's not to say that it can't form outside of that. In fact,
no, we've seen more activity all over the world outside of the seasons as of late, for sure.
The remnant of Hurricane Rosa was important in the beginning of October.
Yes.
Then that second event, I believe, was not related to a tropical storm, but was more of a cutoff, close low.
Yeah, and I think we can even step back and say that we have to kind of make that distinction that it's very rare for the proper remnant circulation. And again, making that distinction of a hurricane is of a specific magnitude and is typically over very warm water, and that's what sustains it and can either cause it to increase in intensity or to actually sustain it, right? And so these storms weaken typically when they're disconnected from the warm water. And so there's a sharp gradient in that warm water in the East Pacific. So as these storms move north, they typically fall apart pretty quickly. And another way for them to fall apart is to interact with land masses. And so coastal tropical storms in Mexico are usually torn apart by mountain ranges, whereas you don't have that in the Gulf of Mexico, right? So those storms they'll disconnect from the ocean water, but they don't interact with topography. The storms here, like when they move over the spine of the mountains in Baja, they're usually torn apart. And so that is typically, it's not good for Baja because they're taking it on the nose. Right. But for us, we don't end up having proper tropical storms typically make it all the way up here. Yeah,
it's very rare. And when you do, you kind of have to have, the right conditions for it to actually get a direct hit. Right. And I'm remembering a few years ago.
Yeah, it was
Odile.
It was Odile, wasn't it? Yeah, where we were watching the remnant, but it was like weakening, and it had decoupled, meaning that the surface circulation and the upper level circulation had decoupled. And these storms they're stacked, so the lower circulation, the upper circulation are synced and they feed each other. And as soon as they're disconnected, they're separate weather features at that point, and they can't sustain each other. So I think even with Odile, we had a surface remnant, and that's what we call it, remnant, because it's a remnant of the initial storm, right? Right. I'm just making this distinction because the storms that we had, and that Rosa was remnant circulation, and so it's primarily at that point it's moisture, and there's not a lot of dynamics associated with it, and so it's typically super soupy air, and then hopefully you have some other weather feature like an approaching trough, which we do at this time of year, to destabilize the upper levels of the atmosphere. And so then you just create like autoconvective situations where it's just somebody coughs and a storm forms, basically.
So when you say the remnant usually doesn't have dynamics associated with it, that basically means that in that particular area there isn't uplift. That's occurring. That there needs to be some other. The storms themselves can generate uplift.
Yes, right.
When they're fully functioning.
Yeah, they have temperature gradients, vertically and horizontally that will help sustain the convective processes. Yeah.
So then for us, like you basically just stop the circulation as it goes over the land, and you're just moving this big pile of moisture into a region. Uh-huh. But usually when you do that, there is the other conditions present to generate rain, right? I mean, I guess
not always.
I guess it doesn't take a lot though when you have a whole bunch of moisture moving in.
That's true, right? We've had the situation where we can have massive slugs of tropical moisture move into Arizona, and they don't do anything other than make clouds. But we can also have situations where they can, create, sort of self-sustaining mesoscale convective complexes, and that can then turn into vortices, if they're sustained. Like Norbert was that, where we had so much moisture that the atmosphere was just absolutely unstable and just rained out in the lower elevations. So Rosa if I'm remembering correctly, was a little bit of both, which was a lot of moisture, a little bit of remnant circulation, but also interacting with an approaching trough, which would help with some of the upper level dynamics. And sort of it moves it forward, which is important, has some forward momentum, and then some upper level dynamics to help sustain some of the rainfall. And that's what you saw. You saw bands of rain, multiple bands of rain training, moving over areas for long periods of time.
What about later in the month, Sergio, which was the other tropical storm that recurved into south of us and influenced us? The precipitation expression was different. In fact, it was much more Sergio, which occurred mid-month. The precipitation amounts are basically confined to southeastern Arizona for the most, the southern half of Arizona with a higher concentration in the southeastern corner, and not so much at all in the northern stretches of the state. Conversely, Rosa, you can actually see a clear trajectory of where that sort of the low moved over.
That's true. That's actually right.
And it went sort of northeast. It entered in, I don't know, my geography, Mike.
That was right over Tohono O'odham. Was the
Oregon Pipe,
mostly Tohono O'odham.
And it moved basically from there northeast through Flagstaff.
I'm really glad there's two of us. I think together our brain can reason out some of this climatology. That's right. And so Rosa, as I'm sort of reconstructing my memory, the remnant circulation approaching trough, helping to sort of move and kick Rosa off to the northeast, was multiple sustained bands of rainfall. And that's actually where Tohono O'odham got between 5 to 7 inches over, I think, a day or something like that. And that's also where it ran up into the Phoenix metro area and then rained out on the mountain ranges north of Phoenix. So I think that was like that kind of direct hit, right? That thing was a thing, and it was moving forward and rolled in there. Sergio was more like Bud, if I recall, which was, it was like a slingshot of moisture towards us. But then the real work was done by the approaching trough of low pressure. And that was the cool thing about October, was that you had all this tropical storm activity in East Pacific, and you just had tropical moisture just parked, just to the south of us, just waiting. And then we had a really quite active mid-latitude storm track that was digging down. We had a mean trough, basically. So there's a mean, if you averaged out for the whole month.
An angry trough?
That's exact. I never thought about mean trough as that way, but you're right. It was a mean trough, both in the statistical sense and in the aggressive sense, that was moving lows pretty consistently through and near us, dropping them down. And the weather map you have up right now is right for the mid-month of October. That's actually what we would call a Rex block situation, which is a high over a low. And that tends to be a very slow-moving situation. You don't have a lot of movement in the forward direction. So that, that's a great place to put one of those, and to have some tropical moisture. You're probably going to get some good rain out of that for the Southwest.
Yeah, and we did. In fact, Rosa was more intense, higher precipitation accumulations for some parts, but not for Tucson. Sergio in that mid-month of October generated more rain during that period for southeast Arizona. And then, okay, Mike, so then moving along, sort of concurrent with Willa, the third hurricane in October, that sort of recurved into this recurved into Sinaloa in Mexico, so pretty far south.
Yeah, and then moved into Texas.
And then moved into
trouble
Texas.
There, yeah.
That was concurrent with, but probably didn't. The rain event here in the Southwest probably didn't tap into that.
I don't think so. I think that at that point, this is, we're transitioning and everything is sinking south, right? The intertropical convergence zone is sinking south. The sun angle is sinking south. So everything's kind of moving away from us. At that point, the lows are now, we're getting disconnected from the subtropical moisture that's straight to the south. That, I believe, Willa was picking up something that was more mid-latitude, Pineapple Express-y, kind of out in the central to eastern Pacific, moving across there. Yeah, so troughs coming through can pick up those filaments. It was not an atmospheric river, but it was not all that unlike that sort of trajectory.
I think when you look at the water vapor images, you can see a distinction between like
pulling apart.
Yeah. But that it's not that the water vapor from Willa is not actually being entrained into our area.
Yeah. Just that synoptic setup where Willa was making landfall and where our approaching trough was, it would be really difficult to move the moisture in our direction at that point. And it's getting late. It's, by the end of the month, stuff starts to really shift around.
By all accounts, October for nearly all of Arizona was a pretty active month. There was a lot of rain, greater than 4.5 inches in many parts of the southern half of Arizona.
Yeah, the picture across the state was record wettest for southwest Arizona. So kind of what we talked about, Tonawanda, far western Pima County, parts of Yuma, parts of southern Maricopa County. Record October wettest.
That's substantial.
Yeah, and it's interesting when we were kind of piecing this together, as you mentioned earlier, 1972 was the record wettest, and I even remembered that I wrote this up in a paper talking about October of 1972. That was a year where we had very similar. We had a landfalling tropical storm Joanne, and then multiple days of Joanne moisture getting moved up with a cutoff low, basically assisting. So not all that unlike what we saw this month, but just the right setup that put as much rain as we've seen across the whole state. It's not to say that it's not the flood of record or the wettest for any given location. It was just that all of Arizona in the statewide ranks for the last 120 years, that was the wettest October record.
Concurrent with all of that, precip brought cooler than average temperatures, and so you look across the state, and it was fairly cool. In fact, I remember thinking we had this abrupt transition to like Southwest winter.
I know.
Right after the monsoon, it was like, geez, there's no like middle ground here.
I think that we've been traumatized by the last couple of falls. I mean, I think that
being pretty warm.
Oh my gosh! So remember last year? I'm not a guy that lives in the past, even though I guess I'm a climatologist, so that makes it complicated. Last
You're
summer,
always living in the past, man.
Yeah, apparently. Last summer.
Welcome to the now.
I know, it's right. We live in the present, man. Last summer, we had the monsoon. We had the July that we still, I think, live out in our dreams. Even though this was this last July was great, but the previous of 2017, monsoon shut down in August. And then we didn't have anything in September. And then it got hot in October. And then it got hot in November. And then it got hot in December. And it was like summer just wouldn't end. Like we were in the 90s for much of October. And then I think even into November.
Endless summer. You're right, though. It was. Yeah. I remember it being annoyingly warm.
Yeah. I mean,
this year I remember it being like annoyingly cool.
It was fantastic. You
can't please me, man.
I've been wearing a different coat from my closet every day just to like make sure it's, moths haven't eaten it and still works, stuff like that.
Okay, so I'm conscious of time here, and we still got a lot to cover. Okay, so let's say October 24th, 25th, that's basically when the precip shut off. And since then, it's been dry as a bone.
Yep, nothing.
And we've, when I was looking at the weather maps, I mean, basically we've been on the sort of western side of a trough.
Yeah, yep.
And so that's actually helped cool down. Brought cooler air from the north, but it's on that western side, which doesn't make it favorable for precipitation, right?
Nope. The mid-latitude jet, we've not been like parked under a ridge. That's normally where we are.
And that's probably what happened last year.
Yeah, we're just parked under a ridge. High pressure, heat, blah, blah, blah. So it's super boring and uncomfortable, and it's hot. And this year, jet's been active, a lot of bobbing around. A lot of the lows moving in, the troughs moving in, were kind of coastal landfalling troughs. And then just since late October into the last couple of weeks, as you noted, we've had sort of a strong ridge over the East Pacific. And then we've been on as you said, the west side of the trough. So that's caused a lot of cold air to pour in from the Great Plains all the way south into Texas. And so it's been in the teens in like Nebraska, I think. And it's been super cold. But the interesting thing is that whole pattern has caused basically Santa Ana-like conditions, right? And so a lot of our cool down has been howling cold winds out of the east. And so it's been cold air pouring in from the east across New Mexico and Arizona, trying to make its way out to the warm ocean right there. So it's cold air sort of flowing back towards the sea. So it's been cool, but also very dry and very windy.
So I want to come back to that because I think that's important, particularly in the context of what's going on in California with the fire season.
Yeah.
But before touching on that topic, what causes the jet? Why are we having such a meandering jet stream this year, whereas last year it wasn't as much?
I don't know, man. It's like a $10 million question. And this is where we have to, if we knew, then we would have predictive capacity at, some of these times. Like if there was a single causal mechanism, we could say that thing is there. So then for the next several weeks, we will expect this thing, right?
It's kind of all upstream stuff, right? And it's
totally upstream
and then
stuff.
you're just circulating the globe. It's like, where does it end?
Yeah. So
you're
we
just
can
chasing your tail.
We can go through all of the culprits. It's going to be change in mean state across the Pacific, which would be sort of ENSO moves, which will over time influence weather patterns, but aren't, the weather's still going to be the weather. We can have the Madden-Julian oscillation, which is starting to kick in, and it could have been part of the upstream forcing in the jet stream. There's the whole Siberian snow cover thing, which is an October-ish thing, which we start to see if that's going to then play downstream. I don't think that's probably on the weather timescale. It can be on the weather timescale. The Arctic oscillation, sea ice extent at the north. What other fun things do we have out there? I was kind of paging back through, and you can see like some of the indices, like Pacific North America pattern. It's just a pattern. It's just like a way of describing.
Right. It doesn't talk about the causal.
It's not predictive. No. And it's not causal. So it was in a pattern for one half of the month, and then it flipped the second half. So it doesn't really say much. It isn't related to ENSO, but probably not this time of year, and ENSO hasn't really kicked in, which we'll talk about. So I don't really know.
Yeah.
I mean, and there's going to be the sort of weather timescale adjustments to the system as we're moving from fall into winter.
It's interesting though, because I mean that pattern itself has a lot of influence on what the rain and temperature
totally.
does
Yeah.
in this particular
season. This is why, as we'll talk about, I mean, like why the correlations between ENSO phase and total winter precip is 0.5. There's a lot of room for other things to get in the way there. There's some information in there, and it gives you a lean, but it's not the perfect determinant of a location's weather for an entire season.
Yeah, it's kind of interesting. I mean, like it is this fluid dynamics problem, which is why you have these jets and loop and
it's weather forecasting. Weather forecasting is hard. It's really hard. And the more you ask of it, for very specific locations, for very specific variables at longer timescales is where you're really, really pushing it, which we do, man. We push it. Well, we're mostly wrong. That's also, I think, why.
Okay, so I think you had a nice segue. Okay, well, you mentioned before about the Santa Ana winds, and I think it's worth talking just very briefly about their role in California fires, which for the second year in a row, and this year is particularly tragic.
Yeah.
I mean, some of the news that's coming out from the Camp Fire, which to date has burned nearly 152,000 acres, but that is an understatement of what it actually means. 15,000 structures, 70 reported deaths so far, and hopefully that number doesn't climb. But this is, by all accounts, the most destructive fire in the history of the U.S., I would think. I mean, I haven't looked that up, but I look back on some fires in Arizona and the Yarnell fire a few years ago, where 19 of the firefighters lost their lives. At that time, it had been the most, in terms of human lives, it had been not since 1991 had there been more deaths. By whatever measure, it doesn't even matter in terms of putting it into some sort of historical context. By any measure, the fires in Northern California and actually around Los Angeles have been particularly devastating.
Is the Chicago fire of 1871 killed 300 people.
Yeah, that's important as well, because that's an urban fire.
It was, and this was an urban fire too.
It was an urban fire, except it's at the urban wildland interface. Which Chicago is
In the 1870s, it was too.
That's a good point.
So it started in a barn, so I don't know. It's not that different. I think that's the interesting thing about the fire here is that we haven't seen any contemporary things. Like in the 1800s, that was fairly common to have these large fires. It's not that common anymore. And that's why I think it's so absolutely striking to have towns burned down. We're used to seeing large fires across the West, but they're out in the middle of nowhere and they burn down a cabin. And we've got fire lines of Forest Service firefighters, but they're not urban fires.
Right. This is moving house to house.
House to house. And it was burning the houses more than it was burning the surrounding vegetation. The houses were carrying the fire, which is just
15,000 structures.
It's
15,000 homes.
Just nauseating.
Just flattened the entire town of Paradise.
Yeah.
So what were the conditions that maybe led up to this?
The Santa Ana winds, they originate when you have cool air masses that turn into these inland high pressures. So you can have cold air moving in. It's usually continental air masses moving out of Canada, and they'll slide down into the Intermountain West. And so that cold air is heavy. And the ocean water is much warmer, right? Mm-hmm. So you have this pressure differential that's set up by having warm, moist air out over the Pacific Ocean, which is of lower pressure, and you have higher pressure inland. And so it's basically like water, behind a dam.
Squeezing a tube, yeah.
Yeah, it's water behind a dam, and the mountain ranges, they're not contiguous. They can't dam. You can actually have situations where you can dam cold air behind air masses. And it's permeable in these passes. So this high pressure, this cold air is going to actually move through passes to move towards lower elevations and to move out to the sea. And it's going to accelerate when it moves through these passes.
Right. And it's also rolling downhill.
It is. And it's at the same time, it's compressing and it's warming and it's drying out. So as you have that compression of moving to higher atmospheric pressures at lower elevations, you're going to dry out the air, you're going to warm it up, and the speed of it
and you're creating that wind. It's 50, 60 miles an hour at times.
Yeah, and so this has been the real issue in California is that a lot of these fires end up being started by down power lines. And so Pacific Gas and Electric has had issues over the last couple of years where they've started fires in the past couple of years that have led to enormous destruction across California. So they've been de-energizing lines. And so they now have to get into this situation where they have to anticipate these Santa Ana wind events and then power down the lines. And so I think this was a situation where there's some discussion that they didn't heed the forecasts well enough and they didn't have a good enough idea of where their power lines were susceptible to these wind events that can do it. So it's like this constant learning. So the other aspects of this fire is that California's had some amazing reversals in precip over the last 10 years. And so they've had long-term drought conditions, warming temperatures, killing off trees, wet conditions, growing up vegetation. So, those conditions where you're in a high biomass Mediterranean climate that is prone to fire, also background warming, background drought conditions, and this entangled wildland-urban interface is just, it's a bad scene, and it's a huge risk.
California typically has its peak in fire season at the end of the summer. They don't get any rain then. And then in November, rain starts to fall and it moistens the landscape and it sort of tamps back that risk. Well, it's been warmer than average. And also the rains, I believe in October, California on average gets about 3 inches of rain. They saw 1/10 of an inch. So It's been really dry in October.
Yeah.
And then, in November, they get close to 7 inches on average, and there hadn't been any rain in November up until this fire.
The timing, yeah. It's just a knife edge of the timing.
So when I was thinking about this, what does it take to have a fire? Well, you have to have some fuel, and it has to be flammable, right? Yeah. But then what does it take to generate a large fire? Well, you have to have these amplifiers, right? Like the wind being one of them.
Yeah.
Maybe the duration and intensity of dry conditions prior to that is an amplifier. Maybe some unhealthy forest that could be thinned out or that hasn't been managed to the degree that maybe it could be. And then, maybe even like slow response or insufficient response to deal with like the initial, fire when it happens. I read a couple of articles where in Paradise, the escape routes were they weren't big enough to traffic a number of people out in time. And so there was a couple of routes to get out, and there was traffic. And so there's all of that, all of those variables sort of come together in these kinds of perfect storms.
It's a convergence of just a lot of, a lot of those aspects that, how do we think about these situations in the future, right? I mean, where can we do better risk assessment of communities? And this is something I think we should explore in a future podcast about Arizona, about what, can something like that happen here? It's a very different ecosystem, very different wild and urban interfaces, different seasonality. But, these are...
But I think why couldn't it happen?
Well, I think it could. And I think that when we think about communities across the state, I think that, remember, that part of... I was talking with a friend in Northern California who pointed out to me that this is an area that gets 80 to 100 inches of rain a year in one season. It's Mediterranean climate, right? So the biomass production, if you think about how do you manage the biomass of a system that is that.
Right. It's just totally producing. It's ramped up. It's an overdrive because of the rain.
Right. We don't have that necessarily in Arizona,
That's
right?
True.
I mean, like our wettest places are 40 inches or something like that. And so the ecosystem, you can get ahead of it, I think, and manage it a little more easily when it's of a lower productivity, right? And so when we think about the fires here, we're really off. This would be another podcast for sure. We have ENSO variability, which can produce fine fuel structure, and we can connect areas, and we can see that in historical fire records. But we do have problems with wild and urban interfaces across Arizona. We do have communities at risk. We have programs like FireWise, which I think are super useful that we probably need to lean on a little bit harder, and we need to learn from some of these events. But California has its own unique set of risks because, and I really think this is a distinguishing characteristic between the Southwest and California, one season of precip, a very long fire season that's been getting longer, it's getting warmer. That climate change aspect is absolutely in that system, and just that tangle of things. And I think the things that you pointed out there too, and that those populations are a lot of retirees who had special
vulnerable
needs.
Populations, yeah.
Like at a community that's not, absolutely wealthy, the capacity to think through that worst case scenario, which is
do anything about it.
Yeah, I mean, to really get ahead of that and then have the situation for this is, very few communities I think are going to have that.
Well, it definitely calls the need for increased preparation. Across all
absolutely,
across
and
all
I think
fronts.
It's everything that you said. It's everything from weather forecasting and using climate information to the utilities trying to think. I mean, utilities now are
right. I think there's a lawsuit.
Being sued. Yeah. So they've got a big thing to worry about there, to the risk management side of it, to the fuels treatment, there's just so much to the disaster preparedness. I mean, it's still going on. The fire's still burning. There's the fatality we don't know yet. And so I think that, at this point we're just, thoughts with everybody out there, and, we can be, sort of more pundit about it later.
Right. Yeah. Okay. Okay. So that gets people caught up to now.
Yep.
We're living in the now, Mike.
Finally.
Just a quick production note. Zack and Mike had so much to say that we're going to release the podcast in 2 parts. The first part will be what you just listened to, with a recap of the monsoon, the October rain, and fire in the Southwest. The follow-up will be about ENSO or El Niño and the forecast looking forward. Thanks.
All right, Mike. Thanks again.
Thanks, Zach. Catch you next month.
Thanks, everybody.
Happy Thanksgiving.
Yeah, happy Thanksgiving. And thanks for Ben. I think he's going to get this out before Thanksgiving.
He's got about 2.5 hours of editing to do content.
He can do it. He's the man. All right. Cheers.
The Southwest Climate Podcast is a production of CLIMAS, which is part of NOAA's Regional Integrated Science and Assessment Program and is housed at the University of Arizona Institute of the Environment. Mike Crimmins is a principal investigator with CLIMAS, a professor of soil, water, and environmental science in the College of Agriculture and Life Sciences, and climate extension specialist with the University of Arizona Cooperative Extension. Zack Guido is a research scientist with the Institute of the Environment and UA program manager of the International Research and Applications Program. The podcast is edited and produced by Ben McMahon, research, outreach, and assessment specialist with CLIMAS.
Were you listening?
What were you saying? No, of course I was listening.